we want to continue with the concept of time value of money. And in our previous lecture, we focused on annuities, whereby we looked at ordinary annuities and annuities due, whereby we defined an ordinary annuity as an annuity that is as an annuity which represents a payment or a receipt that is made or paid at the end of the period, whilst an annuity due, we are saying it's a receipt or a payment received or made at the beginning of the period. So our first part of call, we are going to focus on amortization. So basically, amortization, we use it especially in discharging of debts, discharging of loans, whereby we are saying with amortization, it represents the payment or the repayment of both the principal amount plus the interest borrowed simultaneously, such that at the end of the tenure of the loan, there will be a zero balance. For example, if someone borrows $10,000 for 5 years at an interest rate of 10% per annum, we are saying at the end of 5 years, that person or the borrower should have paid the 10,000 plus the 10% interest per year, such that at the end of the 5 years there will be a zero balance. That is what we are referring to as amortization. So with amortization, we are just using the principle of the present value of an ordinary annuity, whereby if you recall, with the present value of an ordinary annuity, we say that present value of an ordinary annuity equals to R times present value interest factor annuity of an ordinary annuity. But recall from our previous lecture that we can rewrite this. So when we are rewriting it, it's R is equals to the present value of an ordinary annuity is equals to the present value interest factor annuity of an ordinary annuity times R. If we rewrite this, it becomes 1 plus R to the power of n minus 1 all over I bracket 1 plus I to the power of n times R. So is equals to the present value. So in this case, when it's amortization, our main port of call or our main one is we'll be looking for the periodic repayment. When you approach a bank to borrow money, their main one is how much will the borrower be repaying per period. So that is our main port of call, that is our one when we are looking at amortization. So which means we are supposed to make R the subject of the formula. So if we make R the subject of the formula, it becomes R is equals to the present value all over 1 plus I to the power of n minus 1 all over I bracket 1 plus I to the power of n times, okay, just like this, okay, because R we've made it the subject of the what? Of the formula. So in this case, to make R the subject of the formula, we simply divide both sides by this what? Theta. So that is what we are referring to. So which means when you've got this, there can be circumstances or there can be scenarios whereby we are compounding more than once. If we are compounding more than once, as we said in our previous lecture, we divide our interest by the number of times we are what? We are compounding, and we also multiply our time by the number of times we are what? We are compounding. So if we are going to rewrite this, it will become, okay, let me rewrite it next to this one. So it will become R is equals to PV over 1 plus I over M, the number of times we're dividing, times N times M minus 1 all over I over m bracket 1 plus I over m to the power of n m. So this is when we are compounding more than once. Okay, so let's look at an example. So this is what I'm trying to say, that you divide the present value with the present value, interest rate annuity, and the present value interest rate annuity translates to this, translates to that. That is what I'm talking about. It translates to this, and we make R the subject of the formula because this is our headache. And obviously, when you're dividing more than once, you divide each and every part with what? With M. Remember, we say Jm is equals to I is equals to R. It can be used interchangeably. Okay. So let's look at that example. FM borrows 100,000, which should be paid off by 3 equal installments made at the end of each year. The applicable interest rate is 12% compounded once per year. Determine the monthly payment and construct an amortization table splitting capital from interest payments. So when it's like this, we are supposed to identify our variable.